Hello everyone, in this video we're going to explore topic 10.5 harmonic series and P series of AB calculus BC. Now let's talk about the definition of P series. A P series is an infinite series of the form sigma of 1 over n to the p when n goes from 1 to infinity. Now, if you populate this series, it's going to be 1 over 1 to the p plus 1 over 2 to the p plus 1 over 3 to the p, etc. until 1 over n to the p, where p is a positive number. Alright, so keep that in mind. Now, example number 1. Which of the following series are P series? We need to rewrite this one as sigma when k equals 1 to infinity of 1 over k to the 0.8, right? So P equals 0.8 and it's going to be positive, right? So you say yes. Now question B, we're going to rewrite this one as sigma when n goes from 1 to infinity of 1 over 2 to the n. Now look, p must be a positive number, not a variable, right? This one is the variable, so we say no, right? Now question C, it's going to be sigma of 1 over k to the 4 when k goes from 10 to infinity. Now, the starting index does not affect the convergence, so we don't have to worry about this one. What we need to worry is this guy right here, right? So p equals 4 greater than 0, right? So we're gonna say yes. Now question D, this one not a P series, right? Now question E, yes, because P equals 1, right? It's going to be right here. Now question E is the special case of the P series that is called harmonic series. Now theorem 10.5, a convergence of a P series. Alright, the P series is convergence if P greater than 1 and divergence if P greater than 0 less than or equal to 1. Alright, example number 2, we're going to apply the P series theorem. Alright, determine whether the following series converges or diverges. Now we need to rewrite this one as sigma when k goes from 1 to infinity of 1 over k to the 3 over 4, right? So p equals 3 over 4 less than 1. Then this P series diverges, right? Now question B. Again, the starting index does not affect the convergence. Alright, so we don't have to worry about this guy. Now for this guy right here, we just left m equals n minus 1. So then this guy becomes sigma of 1 over m squared when n goes from 4 to infinity. So p equals 2 greater than 1. Then the P series converges, right? Now question C. This guy is not a P series because the base right here and this guy right here different, right? However, this one is a geometric series. Alright, so this one can be written as 1 over e squared plus 1 over e cubed plus 1 over e to the 4 plus etc, right? So the common ratio is 1 over e, which is less than 1. So this series converges, right? Now example number 3. Determine the convergence or divergence of the following P series. Alright, so we just rewrite this one as 1 plus 1 over 2 square altogether power of 1/3, right? Plus 1 over 3 square altogether power of 1/3 plus 1 over 4 square altogether power of 1/3 plus 1 over 5 square altogether power of 1/3 plus etc. Right? Now 1 right here, I can rewrite this one as 1 over 1 square power of 1/3, right? So I can rewrite this one as a series. So it could be sigma when n goes from 1 to infinity of 1 over n power of 2/3, right? Because if you multiply 2 by 1/3, 2 by 1/3, you get every single thing should be 2/3, right? So this guy actually the P series where P equals 2/3, which is less than 1, right? So the series diverges, right? Now we're gonna move on to the next one, the harmonic series. This is a special case of a P series. Why? Because the P right here equals 1, right? So then we have this guy right here. So remember, if P greater than 1, the P series converges, right? If P greater than 0 less than or equal to 1, the P series diverges, right? So the harmonic series always diverges, right? Because P equals 1, right? So it falls into this case, right? Now let's take a look at example number 4. Which of the following infinite series converges? Now number 1, we just rewrite this one as sigma of 1 over n power of 1/2 when n equals 1 to infinity, right? So P equals 1 over 2 less than 1. The series diverges, right? Now, question 2. This is power of negative n. We can rewrite this one as sigma when n goes from 1 to infinity of 2 over e power of n, right? And this one is not P series. This guy actually geometric series where the common ratio equals 2 over e less than 1, right? Because e equals 2.171828, right? So then the geometric series converges. Now question 3. This guy actually the P series where P equals e, which is greater than 1. So this one is convergent, right? Now the question asks us to find the series that converges, right? So 2 and 3 correct, so the answer must be E. Now question B. We're gonna rewrite this one as sigma when n goes from 1 to infinity of 1 over 3 raised to the n, right? This is not a P series. But this one is a geometric series where the common ratio equals 1 over 3 less than 1. So the series converges. Now, question 2. We can use the integral test or we can use the P series test by letting m equals 3n plus 1, right? So this guy becomes sigma when n goes from 1 to infinity of 1 over m cubed, right? So P equals 3 greater than 1. So then the P series converges, right? Number 3 can be written as sigma when n goes from 1 to infinity of 1 over n power of 1 over 5, right? So p equals 1 over 5 less than 1. So the series diverges, right? Now we need the series to be convergent. So only 1 and 2 correct, right? So the answer must be D. Now question C. Which of the following infinite series is a divergent P series, right? So in order for the P series to be divergent, P must be less than or equal to 1, greater than 0, right? Now question A, this guy not a P series, this guy actually geometric series, right? Where the common ratio equals 1 over 4 less than 1. So the series converges, right? Now B can be written as sigma of 1 over n power 1 half, right? When n goes from 1 to infinity. Now this guy actually the P series, right? Where P equals 1 half less than 1. So this one is divergent, right? Now C can be written as sigma of 1 over n raised to the 3½ when n goes from 1 to infinity, right? And this is actually the P series where P equals 3½, right? Greater than 1. So this one convergent, right? Now D, this is not a P series, right? However, you can use the integral test or n-term test to determine the convergence of the series. Now the question asks us to determine the divergent P series, right? So the answer must be B. Now question D. Which of the following is not a P series? A can be written as sigma of 1 over n to the third when n goes from 1 to infinity, right? This guy actually the P series, right? Now question B. This guy actually harmonic series, right? C. This guy actually the P series, right? Where P equals pi. Now D. This guy not a P series, right? Because this guy right here must be a variable, not a constant, right? So the answer must be D. Now question E. Which of the following is a harmonic series? You know that harmonic series P equals 1, right? So we look at this one right here. Answer A is wrong, right? Because this is multiplication. Answer B, yes. P equals 1, right? So yes. Answer C, no, right? Because this guy is not infinitive, right? Answer D is no, right? So the answer must be B. Now let's move on to question F. Find the positive values of K for which the series converges. Alright, so in order to do this one, we need to rewrite this one as an integral, right? So it could be integral from 3 to infinity of 1 over s ln s times ln of ln s to the k, right? Now we're gonna do u substitution. So we're gonna let u be ln of s, right? It's gonna be this guy right here. So then du equals 1 over ln of s times 1 over s ds, right? And it's gonna be 1 over s ln s ds, right? So this guy becomes, when s equals 3, we have the integral form ln of 3 to infinity of 1 over u, right? This one equals u. And this one right here, actually du, right? So I put du right here. And this one power of k, right? Now we're gonna apply the P-series rule for the integers. This integral is now in the form of a standard P integral, an integral of the form antiderivative of 1 over u to the k du converges if and only if k greater than 1, right? And it's your time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.